I want to show you how to solve this 3 by 3 system of equations using Gaussian elimination, or at least the first few steps of Gaussian elimination. In this example, our variables are x, y, and z. I'm going to start by labeling these equations, equation 1, 2, and 3. Now you're allowed to rearrange these three equations however you like. One thing that you'll need is you'll need the first variable to be in the first equation. And it's my personal preference that you have a coefficient of 1 on that variable if possible. Now the first thing that we're going to do with this Gaussian elimination is we're going to try to eliminate the first variable of the second equation. And we're going to use equation 1 to do that. And the same rules still apply. We can still add and subtract equations, and we can also multiply equations by numbers. So in this specific example, if we want to eliminate this negative x term right here by using equation 1, we can just add these two equations together. I'm just going to call that 1 plus 2. And what do you get? Well, x plus negative x cancels. 4y plus negative 3y is just y. 2z plus nothing is 2z. And on the right side, 1 plus 1 is 2. We're going to call this equation 4. And then we're going to go on to try to eliminate the 3x. And I'm going to eliminate this 3x by multiplying the first equation by negative 3 and then adding it to the third equation. If we multiply negative 3 by the first equation, we get, and I'll just copy down the third equation over here. Okay, now if we add these two equations together, we actually get the negative 3x and the 3x to cancel. Now the negative 12y and the 12y cancel. That was really lucky. And the negative 6 plus 7z is going to give us just a regular z equals negative 5. Whatever you get here, I'm going to call that equation 5. And your new system of equations after doing these first two steps here is always just going to consist of equations 1, 4, and 5. And equations 1, 4, and 5 are equivalent to the original system of equations 1, 2, and 3. They'll have the same solution. Now what happened in this example was actually pretty lucky. In general, what happens is equations 4 and 5 become a system of two equations and two unknowns because you've eliminated your x's. So typically there would be a y term right here, and you would solve these two equations for y and z. Then you would take those solutions for y and z and plug them into the first equation to find x. Now we got lucky here because equation 5 just left z by itself. So just those first two steps of Gaussian elimination gave us our value for z. Z is negative 5. So either way, now that we have a value for one of our variables, in this case z, we're going to start the process of back substitution. And that just means we're going to take our value for z and we're going to plug it in to the previous equation, equation 4. That allows us to pretty easily solve for y. I'm getting y equals 12 as an answer there. And now we're going to take our z equals negative 5 and our y equals 12, and we're going to substitute those back into equation 1. And we can simplify a bit, move everything over to the right side of the equation, and I'm getting an x value of negative 37. So our solution is x is negative 37, y equals 12, z equals negative 5. Sometimes we write it out like this. All right, I think I'm just going to stop it there, and we'll do a bunch more of these in class. I will see you there.